Thanks everybody for attending. I know there's competition with lunch right now, so. So my name is Benoît Famchon, and this is my colleague Ronnie Joy. Our third presenter, Najam, is traveling and could not be here. So we are working on identity, access management, and authentication in the cloud protection division of Gemalto, Thales company. And over the years, we've been migrating our application and working from like legacy big monolithic application into microservice using agile methodologies and then transitioning our teams to DevOps and DevSecOps. And as part of this continuous transformation and evolution, we are always looking at ways to ease our deployment and to simplify lives of developers, operations, and DevOps and DevSecOps. So in this talk, we are going to talk about, we're going to present some of the challenges brought by microservices and how some solution like Istio can help address those. So the objective during the talk is to present some specific use cases in order to address those challenges and see how we can resolve them with solutions like Istio. So first, let's do a quick look at the agenda. So we'll cover some of the microservices challenges and dig into some specific use cases. Then we'll do a quick introduction of what Istio is, some of its architecture, and look at 3 specific areas that will be matching some of the challenges of microservices. So the traffic management is one of them. Security and policies is the second one. And the third one is observability telemetry. And we'll get into more detail of each of these areas. And along the way, we'll have some cool demos to show you guys. Microservices are great. Everybody loves microservices, right? They have allowed us to break our big monolithic application into small, dedicated, functional pieces. They have allowed us to get some better scalability. Now, that's nice. We have these 5 little microservices. We may have a couple of programming language used for those. It's manageable. It's pretty cool. But then, as our application gets more complicated and more complex, so does our microservices also. And they can become a real mess, or mesh. As we move into basically management of more complex application or infrastructure, then we run into some issues. Like now I don't have anymore just one language. I'm using maybe some Node, I'm using some Java, some .NET, depending on which technology or features I'm going to use in my application. And I have to deploy my security in all those different components. So imagine I have to deploy my certificates there. I have to implement in each of these microservices maybe some functionality for my underlying logging, monitorings, and you name it. So quite some challenges. So now my colleague Ronnie is going to go into more detail about some of those challenges and some specific use cases for those.
Okay, so yes, as Benoît mentioned, microservices are great, but when you have a lot of microservices, it needs to communicate each other to solve your particular business needs. It comes with a lot of challenges. Let's look at some of them, and then we'll deep dive into our Istio, how Istio can help in these situations. So how do you manage your timeouts? So managing communication between these microservices is really challenging. Also, how do you make sure that you have a timeout in place, you have retry mechanism in place when you talk to APIs, or load balancing or circuit breaking. Let's say that you have a unhealthy instance and you don't want to forward request to that unhealthy instance. You want to break the circuit. So in those cases, Istio can help us. Also, the communication security. So how do you secure your communication? Like, for example, if you want to share some sensitive information between microservices, you probably need encryption, transport TLS encryption. Also, zero downtime deployments. So how do you manage zero downtime deployment? Monitor communication, logging, collecting metrics from your service, tracing. All these areas is challenging in microservice field. So all this leads to code duplication. So you may have to put in your application layer, application code, you have to add logic or you have to add code to overcome these challenges. So let's look at quickly what is Istio and how Istio can help with all these challenges. So Istio is open source. It's developed from teams from Google and IBM with the help of Lyft team who developed the Envoy proxy. So Envoy proxy is a high performance proxy which is used in Istio. And it's platform independent. So what that means is that it's designed to be platform independent. So it can support multiple or container orchestration platforms. As of 1.3 of Istio release, it supports Kubernetes, it supports console, it supports Nomad container orchestration platforms. And it's essentially a service mesh. It does all the things what service mesh doing, manages your communication, it load balancing, service discovery, all those things. On top of that, it provides fine-grained traffic management, where it can, with a configuration, you don't have to write any code in your application layer. You can manage that with the YAML configurations. Security and policy enforcement. This is another area it can help where with the configuration, again, you don't have to put the code in your application layer. So with the simple configuration, you can enable TLS. You can have end-user authentication, things like that. Telemetry collections, it can collect metrics from each of the services. It can also help you with distributed, tracing and or application logging.
Okay, so now we are going to look at the high-level architecture and logical components of Istio part. So Istio is composed of two main areas. One is on the top part, the data plane, which has proxies and a mixer, and basically we'll get into the detail of this element, but that's a core part of Istio. And then we have a control plane at the bottom part. This is basically where all the configuration gets defined and interaction with security components. So let's look at the data plane first. So in your traditional services, you will have, in traditional, let's say, deployment or infrastructure, your services are talking to each other directly. In the case of Istio, it's a little different. So you may wonder why this picture. So I was told I have to put some picture. I didn't have the cat picture, so I put this one. So let me explain a little about that. So this is like a bike with next to it, there's a little platform. It's called a sidecar. So that's a very important concept for Istio. And this one is a high performance sidecar, which really relates to Istio with a very small platform. So in Istio, you have the same concept of sidecar. So for each of your services, along it is deployed a proxy, which is the sidecar. It's a small footprint component that is basically going to manage all the traffic coming in and out of your service. And your service now are not going to communicate directly to each other. They will communicate to each other through the proxy. So the proxy is a high-performance distributed component. For Istio, it is called Envoy. And it has some advanced load balancing features, as well as capability to be dynamically configured through APIs and hot reloaded. And this component is going to be basically enforcing the communication and also collecting data. So all your communication between services, the proxy is able to gather basically data from the request as well as the environment of the request in order to collect them and to send them to another component, which is called the mixer. So this component is a component that is gathering all the data from the proxy and is also a component that can enforce policies. So that's kind of high level of a data plane. So what's important there is basically that we have a proxy that enables the Istio functionality. And the very important point also there is that this proxy allows to deploy Istio without having you to modify your application code. The second part, or the second area, is the control plane. So the control plane has three main components. We'll go quickly through them. So the pilot, which is basically a traffic management component, it's in charge of a service discovery and also the routing and control of the traffic. Then we have a galley, which is basically taking care of the configuration management and abstracting the user configuration underneath. And the Citadel, which is a key and certificate management component. And it's also the component that enable the service to service and the user authentication part. So that kind of give you a quick idea of what the Istio high-level architecture is. Now what we are going to go do is look at three specific areas. So, and for these three specific areas, we are going to see with some demos how we can address some of the pain points and some of the issues from the deployment of microservices.
So Istio's, the first point we are going to talk about the traffic management. So it lets you control traffic between your API, between your services. Istio can control the timeouts for an API or retries circuit breakers with a simple configuration. And it can also help you with stage rollouts like percentage-based traffic split. So for example, if you want to if you want to deploy a new version of your microservice, you initially divert some traffic to it and see how it's performing in a production environment. And then once you're comfortable, you change the whole traffic to that new microservice version. So that's a stage rollout. So Istio can help you with that, with simple configurations and canary rollouts. So we'll see in much detail. We have a demo for this canary rollout. We'll see what is canary rollout also in the next few slides. So we have, okay, so this is our demo. So let's see what is canary deployment. So let's say that you have you have two microservices in your production environment, A and B. B has a version 1. So let's assume that you have a new version of B, version 2, which you want to deploy in production. You tested this version 2 in all your environments, wherever possibly you can test it. But you still want to make sure that it works in production without any trouble. So what you do at the beginning is that you divert some traffic to it, to the version 2. That traffic is only like test traffic. So if your organization tests people log in, it goes to the version 2. Otherwise, all the other users will still using, all the other production users still using the original version 1. And once you're comfortable, you switch the whole traffic to version 2. And that's what canary deployment. We can see a demo very quickly. So in this demo, we have so this demo we have taken from Istio nothing we have built. It's all from Istio. So in this particular demo, we have 3 microservices. The one is product page, which is written in Python, and then the reviews page, which is written in Java, and then there is a details microservice, which is written in Ruby. So these 3 microservices actually together shows a book info application where it shows book information and details and the reviews for that particular book. Okay, so what we're going to do is that we have a new version of review service, which is version 2, which also utilizes the rating service. Now user can rate a particular book. They can also review as well as rate. So that's the new version. So initially, as we discussed before, we are going to flow only the test traffic to review service version 2. And once we are comfortable, we switch all the traffic to version 2. And then version 1 is out of the picture. Okay, so let's see the demo. So I'll try to explain. So I have created scripts to make the demo easier. So I'll try to explain as we go. I'll try to explain what that script contains. Okay, so my first script is I'm going to create this application in my Kubernetes cluster. So this will create the 3 microservices which we need. So at this point, if I go back and see, now you can see the book info application. Here the book details shows what is that book, and then there is review details. So this is the very simple application. Now if you try to log in, I have 2 different users. So let's say that a normal user, Jason, he logs in, he still see the same reviews, and I have a test user so he see the same reviews. So at this book reviews, you can see only reviews, there is no rating, okay? So what we are going to do is that we are going to deploy our new so at this point, we are going to deploy the version 2 of the application, and only test user can see it. So let's go back here. I'm going to sign out from here. Okay. So this is a normal, if someone comes to this page without any user information, he just see the same old review service. Let's say that I sign in as test user. So when I sign in as a test user, you can see that along with the reviews, I can see the ratings as well. So that means that this test traffic is actually diverted to the version 2 of the review service. So let's sign out and log in as Jason, a normal user. He still see the version 1. So what this means is that it's only available, the version 2 is there in production, it's only available to our test users, and they can comfortably test it and make sure that everything works. And finally, let's say that they approved it. Finally, we can switch all the traffic to the version 2. So in this rule, I'm saying that, okay, now switch every traffic to use the version 2. So if I refresh this page again, I can see that as a normal user, anybody comes to this page, I can see the review service version 2, which includes the rating service. Okay, if I sign in Jason, I still see the same thing. Okay, if I sign in test user, just to show. Yeah, so this is the demo for Canary rollouts. Benoit is going to explain what we did, the configurations to achieve this.
Okay, thanks, Ronnie. So basically, now let's look a little bit at what has happened underneath. So during this demo, what we show is how we can deploy a new version in production while being able to test it without disrupting the current production traffic. And then once we are comfortable with the application, basically to change that. So then in the initial setup, we had all the traffic for the review service that was directed to the version 1. Once we introduced the version 2, so what we did is we added a specific rules in order to direct specific traffic. In our case, it was traffic for the end user test that would be directed to review version 2. The rest of the traffic remaining unchanged, and all the default traffic going to the version 1. Once we had tested that, so that rules gets away, and we just go directly to version 2 and change that to version 2. So that's kind of a little quick view of what possibility we have there. Now another interesting set of configuration is in your overall system, how can you manage globally some of the errors or some of the things that can happen? So for example, you can have some timeout or some delays because some services are taking too much time to process some of your data or are overloaded. So you can define globally in your infrastructure or at specific sets of services some timeout thanks to the proxy configurability. Also, you can define how many retries. So let's say your application is going to call an API. First time maybe gets failure. Do we want to retry once, twice? At which point do we decide that this is a complete failure? So you can also get that managed by the proxy. So your application logic doesn't have to be modified. You don't have to implement that in each of your service in all the various language. The third part is basically circuit breaker or max number of connections. So in some of the talks earlier, there was some discussion on that and some mention. So if you want to, let's say, protect some of your application or services can only handle maybe a certain load, that's basically the things you want to do, to say, okay, I can only accept 10 concurrent connections, and then after that, I'll just discard. Once you have set up all your configuration and your policy, there's also a capability in Istio to be able to test them. So you can insert, for example, some delays in order to verify, for example, timeouts, or you can also have some errors that are created to simulate basically failure to connect to some APIs. And another interesting things to mention is the capability to shadow the traffic, or basically to duplicate the traffic. So you can, for example, duplicate your production traffic to another version of maybe some of your application. It will not disrupt your production traffic. Your duplicated traffic will be only sending the traffic, but the response will be discarded. But it can allow you, for example, to see how some other version or application are performing with the same kind of production traffic. Now we are going to switch to a different, to the second area, which is basically security and policies.
Okay, same like traffic management, Istio can help you with security and policy enforcement. So like since there are a lot more communication channel is now open, how do you do mutual authentication? So Istio can help with mutual TLS. It can also help with, if you want to expose your service outside with JOT authentication. So it can help you with that. Also auditing tools, who did what time, what they modified, all those things. It can help you with that. So as a security, it can help all those areas. Now the policy enforcement. So sometimes you want to make sure that you whitelist some of the IP addresses or blacklist some of the IP address or restrict access to certain services or dynamically limit traffic to a service. So those kind of stuff. Or you can even have custom policies to policy adapters. So there is a policy adapter post, and you can have custom policies based on your needs. So let's look at quickly a demo for mutual TLS. It helps to transfer some of the, so if you want to share some sensitive data, it has to be mutual TLS. So let's look at that. So in our demo, we have 4 different microservices. The first one is the front end, and then it calls API 1, 2, and 3. So API 1 and 2 is managed by Istio. That's why you can see that there is a small Istio logo there, API 1 and 2. But API 3 is legacy. It's not managed Istio. So right now, front end communicates to API 1 and 2 non-TLS plain text. But let's assume that you have to transfer some sensitive information between these microservices. So you want to make sure that it's communicate mutual TLS and encryption, all those things. So we are going to show. So the first rule we are going to apply is that enforce all the microservice will accept only TLS communication. So it will reject by default any plain text communication coming to it. So that's the number 1 rule we will apply. So that way, front end try to talk to API 1 and 2 in non-TLS, it will just reject it. Okay? But it can still communicate to API 3 because it's legacy, it's still accepted. Okay? And now that our second rule is that Istio rule says, okay, now all the communication from your container, from your microservice will only TLS. It will only start TLS communication to other microservices. So in that way, now front end try to talk to API 1 and API 2 with TLS. So that way it will get accepted by API 1 and 2. But the problem is now legacy. Try to talk to legacy with TLS. It won't understand, so it will just reject that request. But we can have a special rule for legacy systems. We can say that, okay, if front end try to talk to API 3, then use plain text communication. Just to show that how can we exclude, to have a rule to exclude that traffic. Okay, so let's quickly jump into the demo. Delete. So in this, I'm creating those services which we talked about. And so I'm just executing a script to check the communication. Now you can see that front end can talk to API 1, API 2, and API 3. So it's all status 200. So at this point, it's talking each other in plain text. So my first rule is, so mesh-wide, I'm going to enable the accept only TLS. So all the services in this mesh will only accept TLS communication after executing this rule. I can quickly show you this rule, but Benoit is going to cover more detail. Sorry. So it's very simple. You can see that it's kind mesh policy and name and then peers MTLS. That's all it is. So it will only accept MTLS, mutual TLS after executing this rule. Okay. So let's see what happens at this point. Okay, so it's still getting applied. Okay, 1 second. Let me wait for. Okay. So at this point, you can see that front end tried to communicate to API 1 and API 2 with in plain text, and you can see service unavailable 503 for those two. But it can still front end can still communicate to legacy API 3 in plain text. Okay. So my next rule is mesh-wide service initiate TLS. So essentially, this rule will is saying that when you initiate a communication, all the containers, all the microservices use only TLS. So after applying this rule, front end will try to talk to APIs with mutual TLS. So let's look at what happens now. Now you can see that it's 200 when it talks to API 1 and 2 because it's mutual, it's using TLS communication. But when it's tried to talk to API 3, it's 503 because it's tried to send a TLS communication to API 3, which it does not understand, so it just simply rejects that. Okay. But we can, have an exception for legacy systems, as always. So we can say skip TLS for legacy systems. So at this point, if we try to communicate, if I execute the same thing, it's all 200. Just to remember, in this case, front end talks to API 1 in TLS, API 2 TLS, the other one is plain text, API 3. Let me clear it quickly before I hand it over to Benoit.
Yeah, so in this demo, basically, we've seen how we can enforce mesh-wide security. So now let's have a quick look at what has really happened underneath and what configuration we use. So as Ronnie mentioned, in our first example, we started from non-TLS communication across all the components. And by adding this rule, basically we say that, okay, at the mesh-wide policy, we are deploying TLS. So that means that every endpoint now in our Istio will only accept TLS traffic. But that's not enough. We wanted also to make sure that all the traffic initiated by our services is also basically TLS traffic. So that was the second rule that was applied, which was basically to say that in our Istio mesh, now we want to enforce Istio TLS mutual authentication. So that was the second rule that we applied. But as we've seen, it has broken the communication with the legacy system. So now we had to apply a third rule, which was basically more narrowed down to a specific service. In our case, it was the API 3. And for that specific API, TLS was disabled. Obviously, we don't recommend disabling TLS at all, but that's just an example to see how you can apply specific rules for specific services based on needs that you may have or not. So you can go from a mesh-wide policy and go narrow it down to like specific APIs. So it's very flexible. Now Ronnie is going to talk about authorization and authentication.
Okay, so our third and last demo is JOT. How can we enable JOT authentication for a specific microservice? So in this case, we have 3 microservices, front end, and API 1. So let's say that we want to expose API 1 to outside, and another front end needs to access the API 1. So at the beginning, so let me quickly explain what is JOT. I hope everybody knows JOT, but it's a string. It has 3 parts separated by dot. So the first one is header, and payload and signature. So header is basically contains it's just the metadata information about that token. It contains the algorithm type, those kind of stuff. It's again, the JOT token, it's a base 64 encoded, so if you can just decode it and see what is the content inside it. And the payload is the second part. It contains the user information. So in this case, subject name, issued at. So issued at can be used to, if you want to expire your token. After like 10 minutes, you want to expire your token, so server can see that when is it issued, and then it can expire it. And the signature part, this is the most important part. It verifies the content is not tampered with the shared secret. So as long as the secret is, server can verify with the secret that any information in this token is tampered with. Okay. So now, at the beginning, the API 1 can be accessible, but no control. So anybody can access if they have a URL. And then we enforce the control. So only with a valid JOT. So with a valid JOT can access this service. Okay. And then with a valid JOT, you should be able to access the service. So that's the demo which I'm going to show to you. So in this case, I'm creating those services required and need to create Kubernetes gateways to expose that to outside. So let's see from Postman. So in this case, I have 3 requests. My first request is no JOT, so I'm not passing any JOT information in the header. And let's see that service is accessible. Okay, so it's just a simple HTTP bin service. So yeah, it's accessible without any authentication requirements. Now let's enforce the JOT authentication. Okay, so not that one. So in this, I'll show you what this role looks like in a minute. So in this, we are going to apply JOT requirements for this API. So let's quickly look at what is that. So ignore the HTTP bin, it's the target name is, yeah. So it requires JOT and it has to be from a particular issuer. And this is the JOT verification URL. So JWK's URL. So, and so this is that rule. It simply says this target requires JOT authentication with this specific issuer. So let's go back to access this service without any JOT. Now you can see that origin authentication failed. Now let's access with JOT. So I have JOT, this is my JOT. And authorization, let me send this. So it accepts with that JOT. I have another request, which just shows that it's a valid JOT, but it has a different issuer, okay? So let's send that. It won't accept because we specified in the rule that it only accepts the JOT with a specific issuer. Okay, let me, yeah, I'll give it back to Ben.
Okay, so in this example, now we've seen that after securing the service-to-service communication, we can also enforce the authorization or protect the access to the services. So let's go a quick look at the configuration. So as Ronnie has mentioned, in this example, we say, okay, for the target name API 1, so we are enforcing to basically have authorization using JOT, and this JOT have to be issued from that specific issuer, so that any traffic coming to API 1 will only be authorized if it has a JOT that is valid, basically from that issuer. So that kind of gives you little ideas of the second area that we discussed, the policy and the security. Now, third area that we are going to cover quickly today is observability and telemetry. So thanks to the Envoy proxies that are deployed along each of your application, we are able, or Istio is able basically to gather metrics both at the proxy level and also at the service level. And also it's able to gather metrics of its own component for like self-monitoring, for example. A second part is a capability also to be able to investigate issue by distributed tracing, so that you can, across all your services, basically be able to follow and trace your requests in order to figure out what has failed if there's an issue, for example, because now in our mesh of services, it can be difficult sometimes to pinpoint out which was the original services that created the failure along the way. So that's a capability that is coming from the Envoy proxy, and that's a pretty nice thing. And the third aspect of access log, so basically Istio is capable to generate and format various type of access log. So let's go into more detail on one specific item, which is the adapter model. So the mixer is a component that gathering all this data and telemetry, and it's also have a plugin model. So it's able to interface with external backend and external software in order to transmit or pass some of those telemetry data that can be used, for example, for billing, monitoring, logging, any type of application or type of external application you might need. So let's say, for example, you would like to monitor, for example, the duration request of some of your queries. So what you can define in there is you can define some specific rules that say that I want to collect this request duration, and for my specific monitoring users, I would like to get those data and ship them to my external monitoring services, for example. So that's a very easy and convenient way to plug in and to use external component or backends in your system. One example of plugin is Kali plugin that, if you recall the first demonstration with a book rating system, so that plugin allows you, for example, to visualize your services. So it shows the different services that we had, and also it can show you the version, and it's quite nice. So that's just an example of plugins that can be added and used with Istio.
Okay, so in the beginning of the talk, we talked about some of the challenges, and to overcome those challenges, we end up having duplicate code in our microservices. So every microservice has to have retrain logics, communication, the TLS logics, all those things, like logging, everything has to be in place in your microservices, so that getting duplicated in every microservice. So with Istio, you can, with the traffic management, you can actually have this retry logic, you can have load balancer logic, all this logic. Traffic management, you can use Istio to manage all the traffic management rules. With the security module, you can actually secure the communication between the microservices or end user authentication. Zero downtime, again, you can use traffic management. We saw that how the canary deployment can be done very easily with a few settings. And monitoring communication, again, the telemetry collection module for Istio will collect the service level metrics or access logs or distributed tracing. So that will help you to avoid code duplication in your microservices.
Okay. Thanks, that's all.